Um, sorry. So, okay, so in time series data pipeline, what we do is we get the data, we plot it, and then after plotting, we'll see what kind of trend is there, seasonality component is there, or something like that. If we were not able to get much from that, then we do the decomposition. One is classical, one is another is STL decomposition. You can do that, and from that you can identify what kind of trend or seasonality component is there, and what kind of residuals are there. Okay. Uh, so so if you wanted to build the model, there is something called stationarity in the data, which it should be there. So stationarity means the data has no trend, no seasonality pattern, or no variance in this. That's what is called stationary. Stationary means nothing is moving, right? That's what stationary is. Most likely data is not going to be stationary, but non-stationary. Um, and so if stationary, then build the model. Nothing you have to do, just build the model. Very easy case. Arima or any of this model you can build. But most likely it's not going to be stationary. So what you will do, you will do pre-processing. You will remove trend, remove seasonality, remove variance, something like that, and it will become stationary. So once it becomes stationary, you can again do this ADF test, KPSS test, which will let you know if data is stationary or not, and that will show you the data is stationary most likely, and then we'll build the model. Okay. If not, then we have to do pre-processing. So pre-processing requires removing trend, seasonality, and all. So we'll see what is going to be there in that. Okay. Now, okay, let's see how to do. What left is, let's see what is STL decomposition. Then we'll see what is ADF and KPSS test. Okay. So STL decomposition is it says it's very easy that you have to import STL or STL from stats model library tsa.seasonal. You have to import that. Then you will run it, and you'll get this is a again this is also giving you a plot similar to the plot of classical decomposition, where in classical decomposition you give you seasonal decompose, and here we have done it. There is one difference in this, like I don't know why they have built the library this way, but here you have to call the fit function, but here it is not, like you will get directly without any fit function, right? So you have to call the fit function here and give the data here, and it will plot the graph also for you. So that is also a good thing about it, and you can see this there. Now here there will be no option that what kind of model it is. Is it a additive model or a multiplicative model? Because in STL, it will only be able to capture if there is a multiplicative model. It will not be able to capture if it's a um, additive model, right? So uh, sorry, it will be able to handle only additive model. So I'll something like this. So STL means locally estimated scatter plot smoothing. Uh, that's what Lewis means, and that's what L comprises of. And STL is seasonal trend Lewis decomposition. Okay. Now we get variety in seasonal. One thing we get is variety in seasonal patterns. So you can see that seasonal patterns are varying now. Earlier they were not varying. They were very consistent, right? So I guess it's not the graph, but this is the graph. But you can see seasonal patterns are almost of equal. They look equal, right? But they are not. Seasonals they are changing. Like they don't have equal height. They have a different height, right? But here we will see that that's what being captured here. So STL will be able to capture that, but classical will not be able to capture that, right? It will handle outlier in the time series. So if there is an outlier in the data, then most likely you might have to use STL decomposition, and it will only handle additive data. So if additive data is there, then you can use STL. But for others, you have to rely on the classical decomposition and multiplicative data. Okay. Okay, so this is what STL decomposition is. Now we'll see what is ADF and KPSS test. So let's see ADF test. Okay. Just in case, I'll share you this. This folder contains all the collabs which has been used in the video. So let's see, the next thing is we have to stationary check, correct? So ADF and KPSS will help you in doing this. Let me So before we do ADF test, let's see what is stationary test. So a stationary series is one whose statistical properties such as mean, variance, covariance, standard deviation do not vary with time, or the stats properties are not a function of time, right? And trust stationarity in time series means series without a trend, so there will be no trend or season patterns. Okay, so we need to find constant mean, variance, and covariance. So that's what trend is. Like trend, let's say if something is uptrend, like this, let's say if it's uptrend, then the mean is changing, right? Like let's say if you compute mean of this initial few numbers, let's say it is 100. Here it is going to be maybe 300. Here maybe it is going to be 400, right? So it is like that. So mean is changing, but we don't want. It has to be in a the mean should not change much, right? That's what we wanted. Then we wanted constant variance also. Then covariance is also constant, right? So something like that we want. Now there is a way to identify if the data is stationary or not using visual way, but again, this is going to be difficult. So we'll use ADF and KPSS, but let's see if we can able to do it. So trend is a clear uptrend or downward movement of over time, and mean is not constant due to that, right? So mean will not be constant due to that. Seasonality is a pattern that repeats at regular intervals, weekly, yearly, monthly. So if we see that something is repeating over some periods, some interval regular, then we know that this is not a stationary data. And the spread of data points increases or decreases over time, making the series appear wider or narrower. That is varying variance. Right? So if variance is high, then you know that the data is spread. The data has more spread, and the variance is there, right? So the constant variance is not there. Now let's see from this image. So this whole image, if I show you that you can see D, H, and I, which is D and H, and then I has seasonal component. So you can see there is some repetitive pattern at some interval. So here it's repeating like this. Again, here it's repeating. So seasonality is there. So that's why these three you can discard them from non-stationary data. They are non-stationary. Okay. The trend can be observed in A, C, E, F, I. So you can see A has some trend, like it's going upward. So mean is not constant, right? C, it is going down, then going upward, then again down. So again, mean is not constant. Then in F uh, or E is a downtrend, completely downtrend. It looks like that. So of course, here little bit of trend is there. Okay. Then I also has trend, right? So this is also trend. Seasonality is also I, and it has trend also there. But if you see B and Z, so B and G, you can see this has no trend. It is almost going flat. Now some outlier is there, but that is okay. So you have some no, almost no thing. And how can I say that the variance is not there? Because you can see the values are almost like varying around zero, but not much, right? So of course you'll never get a constant variance. Like let's say no variance, zero variance is not possible. Some variance will always be there, but it should be very small. If that is the case, then we'll work around. Like we can call that as a stationary data. So that's what it's happening here. We have almost negligible variance, and that's why this will become stationary data. Here now, okay, so G is stationary data, but this is confusing. So I kept like this was kept to confuse that is it why is it stationary? It has definitely very high uh, variance. It's going on 2 to 6,000. Now the variance is that, and some it looks like seasonality is also there, but again this is still stationary data. Um, so you'll always get confused if you look at the charts. You can look at the chart, you can identify it, but it will become difficult. So what we can do, we can use some tests which are known to us, with this called ADF test, AD Fuller test. Uh, so there is now how they do testing and all that you don't need to know. You just need to know how you can implement this. Okay, so there's null hypothesis in this, that series is non-stationary. So this is a by default hypothesis. Okay, that series is non-stationary. Like that. Now, and another is alternate hypothesis, that series is stationary. Now, I hope you have done some amount of in statistics too, some amount of hypothesis testing, and you know that if p value is less than 0.05, then we will reject the null hypothesis, right? So you get this confidence interval, uh, confidence, or you get a chart of that, right? Thank you. Yes, this is a good image. So, for example, this means that it has p value less than 0.05, right? Something. So p is less than some alpha. So here alpha value we have taken as 0.05. Okay. Any significance level you can choose, but 0.05 is most likely being used in these cases. And if it is it, then we will reject the null hypothesis. So null hypothesis as of now, our null hypothesis is that series is non-stationary, which is most likely true, right? We know that series is not non-stationary. But if it has to be stationary, then it has to be p value less than 0.05. If it is that, then we can call that as a stationary, right? But KPSS is something opposite to that, right? So opposite means it says the series is trend stationary. Like that's what KPSS is. That null hypothesis says that um, it is a stationary. And alternate is saying it's not stationary. But in this case, what will be the p value you have to choose? Like what p value will what p value should be there, so that you can say that it is a stationary, right? What will be that? Anybody?
0.95.
It should be greater than 0.05, right? That is enough. Like not necessarily 0.95. Let's say p value come out to be 0.3. That is good enough. 30% I got. So in this chart, if you see, let's say this is 0.5 midsection, that 0.3 could be here, or 0.60 could be here, right? Something like that. So it should be in the blue part of this. Um, I mean, this is a different test, but um, according to chart, you might get that, right? So it should be greater than 0.05. If that is there, then you can say that we accept the null hypothesis. We have to accept the null hypothesis. Okay. Something like this. Now, okay, let's import the data. And I have this data I have already made as a date time. you can plot that. Now, if you want to do ADF test, so for that we will import stats model.tsa stats tool, import AD fuller. So we'll do that. Now we have to give, so AD fuller is what I've taken from here. I'll give my data. So passenger data I have to give. Now auto leg, don't worry, you don't need to know that. You can remove that. Okay. So we have to do AD full test. We have to give the data, and then what actually will happen is if you write it's a DF test, so it has all these values, but like some value, right? So t statistics, then p value, something like that. Now what we'll do, we'll just create a data frame or a series where we are writing the indexes and all, and we'll store it. So we are storing DF test values and all in this, and we are printing. That's easier. Like it just makes easier to visualize it. Okay, that's all we are doing. Now you can see test statistic give this score. P value is very high. It is like 0.99. We wanted it less than 0.05, but it gave ADF test gave more than 99. Like we are not even close to say that this is stationary data. Okay, so this data is definitely non-stationary. Lags use, so lags is something they use internally. Lags means how much back time you want to go, like 12 days, 13 days, or in this case it is months, so 13 months. Okay, but you don't need to you don't need to go into that. You can just say auto lag or automatic, it will capture it. Okay, now critical values are something like this. So this critical values you get like 0.5% or 10% or 1%, right? So we use 95% confidence interval. So this is a 99% confidence interval. This is 95, and this is for 90% confidence interval. If you don't understand this, just know this one. That is good enough. You just need to. So two things you can do here. If I show you how to read this, that p value should be p value. You have to read first thing that p value should be less than 0.05. But is that then good enough? Our task is that. Another reason is that this test statistics, right? It has to be less than whatever these critical values are. Okay, so if it is less than all the critical value, that will be good enough. But if it is less than these two values, then also good enough. Okay, so 5% and less than, so critical values test has to be lower than. This is the case we want for stationary data. Okay. Stationary data, that's what we wanted. Now, of course, we don't have it here, so this non-stationary data, and same thing we have to, let's say, test with the KPSS test also. The two sets, and we have to do both the tests. Okay. So I'll import KPSS, then give my data. So this use something called regression thing. Then that will do it. But again, you don't need to go into this. And lags, let it be automatically identify that. Okay. And you get this. Now p value here we are getting 0.01. But in this case, remember, this is where you should have more than 95. Sorry, more than 0.05. Okay, but it is less than 0.05. It should be more than 0, right? And in this case, it's opposite. Test has to be lower than this three values, or at least this two values. Okay, opposite to what we did earlier. That's what we wanted here. But again, like it is same data, so of course we'll not have stationary in this case. Now, okay, so what you can do is what we are doing here. We can write it in the form of function also, so that whenever you wanted to do a KPSS test, let's say if I create a function out of it, I just need to call this function KPSS. So whatever we did earlier, right? Same thing we are doing here. We just need to give the data, and you will be able to get KPSS test out of it. Right? So it just makes easier to do it. That's all. Like you can create a function out of it, and some people do it so that you get it easily. This thing, because if you wanted to test multiple times, then you can't write all of this code again and again, right? So you can. It's better to create a function out of it, and then you can do it. Now, so what we get to know is that ADF and KPSS test can be used to identify if data is stationary or not stationary. That's what we were able to understand. Now, something we can do with respect to the test results we get. So, case one, both tests conclude that given series is stationary, then series is stationary. Okay, that is the best case scenario where both the tests concluded that series is stationary. We wanted that. That's the best test, but of course, we'll not get that most likely. Uh, both tests conclude that data is not stationary. The series is not just stationary. This is also okay. We were able to conclude that the data is at least not stationary. So something we can do later on, pre-processing we'll be able to do, but we were able to identify. Now the third case is very ADF says that not stationary, but KPS says it is stationary. Opposite views here now, right? So what should we do in this way? So in this case, the series is trend stationary. That means trend is not the one which is affecting it, or trend is or to make the series strictly stationary, we need to remove the trend in this case. So we can remove the trend out of it, and then we check the detrended series for stationary. Now, how we'll do that? We'll come or we'll look in the we can look in the next session, but we can remove the trend from it. Okay, so detrended series is something we can form from that. Just remember that something called detrended series is that if this is the result of the tests. Okay, now opposite of that, now ADF is saying that there is stationary, and KPSS is saying that it's not stationary. Then what you'll do? You'll say that series is different stationary. Then in this case, you'll do different series thing, right? So remember that this also. So this two things as of now, two new terms has came up. One is detrending. Detrending, and another is differencing, right? So different series or differencing you can call different series, right? This two term will be there, which we'll use or which we'll learn in the pre-processing segment. That these are the pre-processing methods. Okay, so we'll do that, and if we do this, we'll most likely be able to get stationary data. Okay, so these two things we will do this test. Whatever the test concludes depends on that. We'll do this. Now, what we will do in the both of them said non-stationary. What you'll do? That is very typical test, but where there first we'll do detrending. First we'll do that. If it works well enough, if it doesn't work, then maybe we have to do differencing also. So both we can do. Okay, there is no rule how you can make a stationary data. You have this tool. Some tools are there, but there is no rule of it what to choose. You just have to use all. Okay, here there is no rule. Now, so okay, let's see. So that's what actually next thing is. If we do detrending, what will happen? I'll just show you what will happen, but we'll not look into. We'll look into this into next class. I guess this much is good enough for today's class. So I have my original like passenger data, which has this thing. Now I have made it as a detrended, and you can see there is no trend now. So what we were able to remove, we were able to remove mean weight, changing in mean, right? So now mean kind of constant, like it is around this point, maybe 0 to 15. 50. The mean has now come to a constant value, more or less. Like, of course, you will never have exact one value, but you will have more or less one constant value. And that's what made this series. Now could be this is, if I make a test on this might come, or this might say that this is a stationary series. Okay, still seasonality pattern is there, but again, like, see, sometimes we see that seasonality patterns are there, but if it is not too much seasonality pattern, then the test will tell you that is it a stationary or not. Okay, so that's what the next things we will do. We'll see what pre-processing techniques are. Few are there, only few, and we will build. I guess we'll build a model. At least ARIMA will build after that. Okay, so that's what we'll do in the next session. But that's all I have for today's class. Okay. You can go to this. Yeah, you can go to this. Uh, Link. There will be collabs available, and you can watch the sessions recorded. Uh, if you have any doubts, you can come to the next class and we can discuss over that. Okay. If you have any doubt today, also you can ask. Same thing. Okay. Yeah, that's all I have. If you have any question, you can ask, or we can close it. Okay then. Goodbye, everyone.